Okay, so the last section we're going to look at for this week is 2.4, and that is on solving linear inequalities. So, quick reminder, for inequality symbols, less than or equal to, greater than or equal to. When we're talking about an inequality, those are the four symbols that you will see. So these are different examples of inequalities. The one on the left is just a true statement. There's nothing to really solve there because there's no variable. The one on the right is an inequality that we would need to solve. Right? And the steps for solving an inequality are very similar to an equation. Just have to be careful if we multiply or divide both sides by a negative. Does anyone remember what happens if you multiply or divide both sides of an inequality by a negative? Yeah?
You would flip, you'd switch which direction, or which side would be greater or less. If the left side was greater, it would not be less.
So can you say that again? What do?
So if you multiply.
Could you say it in 3 words or less?
I guess I don't have a good way to describe it then.
Anyone have a? Yeah?
Flip the sign.
Flip the sign. That's it. Yep, flip the sign. So if you divide or multiply both sides by a negative, you're going to take the sign, flip it. Right. That's only if you divide or multiply by a negative. Right. So remember that when that number is a solution, it means that you can plug it in and you get a true statement. Now when you're dealing with an equation, like a linear equation that's not an identity, there is only one number you could plug in. If it was a conditional equation, that would make it true. Right? If you had like 2x equals 12, the only number you could plug in that would make x, that would make it work, 2x equals 12, x would have to be 6. With an inequality, it's a little bit different. There's an infinite amount of answers, pretty much all of the time, that would make it true. Right? Especially a linear inequality like the one we have right there. Right? It is possible I could make an inequality that has no solution, but most of the ones that we work with are going to have a solution. So for example, if I plugged in 5 for x in that inequality on the upper right, is 5 a solution? Travis?
Yeah.
Yeah, because 15 is greater than 12. How about if I plug in 4 for x? Is that a solution? Lens? No, because 12 is not greater than 12. All right. But 5 is not the only number that's a solution. 6 is a number, 7 is a number, 8, 9. Basically anything that's greater than 4. So you have to think fractions and decimals as well. 4.1, that's a solution. So generally, inequalities are going to have an infinite amount of answers. The issue with that is, how do we write it? Well, it's not like with an equation where you can just say x equals, and you just put all your answers right there. You can't list every possible answer because there's infinitely many. So we're going to have to write our answer as an inequality. We can't say it's exactly this number, but we could say that it's everything greater than this number. That's how we would write it. And we're going to talk about 3 ways we can do it. We could do it as an inequality, a graph, or set notation. So we'll look at each one. Remember that some inequalities are a little bit more complex. Like if you put 2 together with the word and, that is a conjunction. So something like x is greater than -1 and x is less than 3. And we talked about that last week. And we can combine that together. And does anybody remember when you combine the 2 together, you're going to get rid of the word and you're only going to have a single x in the middle. Does anybody remember how you could write that? So it's all combined together. Yeah?
X is greater than 1 and less than 3.
So,
-1.
All right, you tell me what to put down. Let's go left to right.
-1.
Yeah.
The greater than symbol would be facing the x. I don't remember if that's greater than or less than.
what symbol do I put here? A greater than or a less
The one
than?
facing that way.
Facing the right,
Yes.
facing the left.
Oh.
So we want it like that.
Yeah. Open parentheses.
Oh yeah,
Right.
well, pointing. Think of it like I think of it like an arrow. It's like
Oh, okay.
pointing to the left. Yep. So less than symbol
X less than 3.
and 3. Yep. So that's how you can combine it. What's another way you could combine it? Kind of the same idea, but just a little, almost like the opposite. But it still would mean the same thing. Yeah.
Just write it in reverse, so do 3 and the greater than symbol, and then X and the greater than symbol, and then negative 1.
Yep. That means exactly the same thing. So the way I chose right there was the -1 was on the left. Yep. So when we're writing a problem like that, this is a problem that there's like a definite start and an end to the interval. It's not like saying you could pick an x value that goes on forever. This is saying to pick everything between -1 and 3. So it's like it's like a line segment if you were graphing it on a number line. Versus the problem I showed you before, where x is everything greater than 4. If you graph that, it's like a ray. It's an arrow that keeps going in one direction forever. So that's what I just said to you. In that particular problem, our answer is an interval that has a number for where you start and a number for where you stop. And in this particular case, you don't include the number that you start at or the number that you stop at because they don't have the equalities underneath. So we're going to talk about different kinds of intervals. Okay, so I'm going to use the terms I'm like an open versus a closed interval, and a bounded versus an unbounded. So they mean different things, and they are kind of opposites. Like if an interval is bounded, like if it was completely bounded, it couldn't also be unbounded. Those are kind of like opposites. But we're going to start out with talking about what's called bounded versus unbounded. What do you think it means if an interval is bounded? Guess what that might mean. A bounded interval, yeah?
Like it's limited, doesn't go on forever?
Doesn't go on forever. It's limited, right? No arrow, not going to infinity. So there are 4 different kinds of bounded intervals. So again, bounded means that there's no infinity symbol, right? Your actual starting point and ending point are numbers. First thing you can have is what we call a closed interval. A closed interval means you're starting at a number, you're stopping at a number, and you can include the number you're starting at and the number you're stopping at. If you want to think of it visually, this is what a closed interval would look like if you drew it on a number line. Filled in circle on A, filled in circle on B. Another kind of interval you can have is an open interval. An open interval that is bounded means you're starting at a number, stopping at a number, but you're not allowed to include either number. So that would look something like this. That's the picture of an open interval that's bounded. So I said there's 4, there's 2. What do you think the other 2 kinds are? Yeah?
So like one of them, one side is closed and the other is open?
Yeah, so a half open or half closed. So we could have a half open interval, which means you're allowed to include one of the endpoints, but not the other. And another half open interval, which is the same idea. So this would be an interval where you close circle on A, open on B, shade between. And And this would be one where we use open circle on A, closed circle on B, shade between. Okay, so those are the 4 different types of bounded intervals we can have. The first number that you write down in an interval is always the low value. It's how low of a number you can pick. The second number you write down is the high value. It's how high does the interval go. You always have to write an interval in that order, low, comma, high. You can't write high, low. That doesn't work. And these symbols we're borrowing from something we talked about before. When I showed you our book and how they do the graphs, they don't use the open circle, closed circle. They use a bracket and a parenthesis. So instead of something like that, you would see something like this. So as long as you remember that the bracket is always a closed circle and a parenthesis is always an open circle, that'll help you kind of remember, oh yeah, open circle means you don't include it, which is what a parenthesis is. Closed circle means, oh yeah, that's the bracket, and a closed circle means you do include it. Okay. So any question on those different kinds of intervals? All right, so now if we have bounded intervals, we also have unbounded intervals. When an interval is unbounded, it will have an infinity symbol in it. So now, instead of saying something like all real numbers, we could say something like the lowest value you could choose is negative infinity, and the highest value you could choose is positive infinity. Now, we would have to think a little bit. Can you reach infinity? So what kind of symbols do you think infinity would have? Brackets or parentheses? Yeah?
Parentheses.
Always parentheses. You cannot put a bracket on infinity. Putting a bracket means you can equal that number and reach it, but you can't reach infinity. Right? So anytime you see an infinity symbol, you will always see a parenthesis next to it. Now, for an interval to be unbounded, it doesn't have to be like this one. This is unbounded because if you were to do this on a number line, you'd basically be shading right and left forever. You're shading the whole thing. But these are all unbounded too. But you're only shading in one direction. Okay. So I'm not going to draw all of them, but this one in the upper left, that would be shading everything from 3 going down forever. The one below it is from 3 and down, but it would be an open circle on the 3. You would not include it. Okay. And the same with the ones on the right. Everything including 5 and up, and then everything that's just above 5. Okay, so those are all unbounded intervals. And technically, there is a 5th type if you do the negative infinity to infinity. That's unbounded on each end. So any question what it means for an interval to be bounded versus unbounded, and open versus closed? Okay, could you have a closed, unbounded interval? Could you have that? Closed, unbounded interval. No, why not, Lance?
Because it's infinite. Because unbounded usually has like infinity, and infinity, there's not really a way to close that.
Yeah, you can't close infinity. Closed means you need brackets on each end. But if you have an infinity symbol in there, you can't put a bracket. So no, you can't have a closed interval, fully closed interval, and have an infinity symbol. That wouldn't work. All right, so now let's practice taking something that is in set notation. That's what this is. and I want to convert it to an inequality. Anyone think they could tell me how I would write this as an inequality? And I'm looking for something with like an x in the middle. Yeah,
-3 is less than x, and x is less than or equal to 5.
perfect. That set notation means exactly the same thing as what we just wrote as an inequality. X has to be bigger than -3, but less than or equal to 5. Any question how we changed set notation to an inequality? Because sometimes on the test I'll say write your answer in set notation, and then somebody's trying to press like the X key on the keyboard and there comes up with an error saying it doesn't let you type in letters. And they're like, well, I can't write it because you're not letting me type a letter. And I'll say, well, read the directions. It says set notation. And then usually they then remember that set notation doesn't have a letter in it. Okay, but so that's important. How about this one? First of all, can anybody describe what kind of interval is this? Using the kind of the vocabulary we just learned. Jackson?
Half open.
Yeah, it's a half open interval. What else? Could you say bounded or unbounded?
Unbounded.
It's unbounded. It's an unbounded, and it's half open. Yep. I could have an interval that's also half open but bounded. Okay, that I could do. All right. So now let's write that as an inequality. X is usually the letter we use. You don't have to, but it's kind of the standard letter we'll go with. Anyone think they could write that as an inequality? Yeah.
-4 is less than or equal to x, which is less than 8.
-4 is less than or equal to x, which is less than infinity. Okay. So technically that's right. Definitely that works. Could anybody shorten that a little bit? Yeah?
You need to get rid of the less than infinity.
Yeah, everything's less than infinity. That I know. If you tell me a number, I guarantee you it's less than infinity. So what could you say that would be a little bit shorter?
-4 is less than or equal to x.
-4 is less than or equal to x, or x is greater than or equal to -4. Okay, if we write it in that standard way with the variable on the left. Is there any question why you don't need the infinity there? Because everything's less than infinity. So. But it's not wrong. It's definitely not wrong. Right? It's just not as concise as you could be. Let's try this one. What kind of interval is this one? Again, just describing it with some vocabulary. Yeah.
Closed bounded interval.
It's a closed bounded interval. Yep. It's closed because it's got the bracket on each end. It's bounded because you have numbers, no infinities. Now, if you said that it was closed, would that automatically mean bounded? It would have to, yeah. If you say that it's closed, you're telling me there's a bracket on each end. If you put a bracket on each end, then you definitely can't have an infinity symbol. Okay. All right, let's write this one. How could we write that as an inequality? Yeah.
-8 is less than or equal to x, and x is less than or equal to 3.
And x is less than or equal to what?
-3.
-3.
Sorry.
Yeah. So -8 less than or equal to x, x less than or equal to -3. Perfect. Any question how we translated that from a set notation to inequality notation? And that's something I would not clarify for you on a test. Like if I said write in set notation and you said, I don't remember which one that is. You just have to know the difference: set notation, inequality notation. All right, let's try this. So now let's take something that's in inequality notation and convert it to a graph. So for this kind of problem, you would have a number line already drawn for you. And how would I graph x is greater than or equal to 2? Yep.
Place a closed circle on 2 and shade to the right.
Yep, closed circle on 2, shade to the right. That's how it'll be set up in pair assessment. How would our book graph something like that? Yeah.
Parentheses, shape,
Put a, say that again?
that parentheses, oh, not the parentheses, the bracket.
Bracket.
Okay.
Yep, so the book would show you a bracket on 2, shade right. Okay. So that's changing an inequality into a graph. Let's try another one of those. How about x is less than 5? How would we? How would we do that one? Yeah, Lance?
Would you put an open circle on 5 and go to the left?
Yep, open circle on 5 and then shade to the left. Perfect. And how about this one? How would we graph that? Yeah, Raj?
A closed circle on -1.
Closed on -1.
And an open circle on 3. And shade in between.
Perfect, and shade in between. And what kind of interval is that one again?
Half open.
Half open,
Bounded.
bounded. Yep. This one was unbounded, and part A was also unbounded. All right. Any questions on translating from an inequality to a graph? Okay, so you should be able to translate between all three: set notation, inequality notation, graph notation. So we talked about that already. So when you are solving inequalities, it's the same steps as when you're solving an equation. The only difference is if you ever multiply or divide by a negative, you have to flip the sign, or flip the inequality. Okay, so that's very, very important that we remember to do that. Not saying that comes up in every problem, just saying if it does, make sure you flip the sign. Okay, so let's see if we can solve this one. So we've got 3 and then in parentheses x minus 1 plus 2 is less than or equal to 5x plus 6. Jane, what would be my first step to solving that inequality?
3x minus 3.
Yep, we're going to distribute that. So that's going to give you 3x. And then you said minus 3 plus 2. What's minus 3 plus 2? Yep, so we'll do both of those at the same time. So we get 3x minus 1 on the left, and then 5x plus 6 on the right. Did we multiply or divide both sides by a negative in that step? Did we? No. So no flipping the sign. Okay. What would we do next? How about Annalise? What would we do next? Okay, so we can subtract 3x from both sides. And what else can I do at the same time?
Subtract the 6.
Yep, I can subtract the 6. And Nick, what does that leave me with now for an inequality?
2x is greater than -7.
Let's not switch anything yet. I see kind of what you're doing, but let's just read it in order left to right, and then we can switch it after.
-7 is less than or equal to 2x.
Less than or equal to 2x. Now, if you want to switch it so the variable is on the other side, a lot of people prefer it that way. That's fine. That's actually a good idea. I would definitely do that. And now we've got one more step. We still got to get x by itself. So my last step to get x alone is
Divide both sides by 2.
by both sides by 2. And we get x is greater than or equal to -7/2. What kind of notation is that? Like if we were describing of the 3 types we've learned, that one is, which one? That's an inequality. Okay. At this point, the directions could say write your answer in set notation or graph your answer. Is there any question how you would convert that to set notation or graphing your answer? In set notation, what kind of interval would it be? Yep. Dan?
Half closed, unbounded.
It would be, it would be half closed, it would be unbounded, and because it's unbounded, that means you're going to have what in it?
Infinity.
You're going to have an infinity in there. Yep. So it's going to be everything from -7/2 up to, but not including, infinity. Yep. Perfect. Okay, so what about solving inequalities on the graphing calculator? Well, there's 2 different ways we can do it using features we've already talked about. We can either do the root, or on other calculators, I think mine, they call it the 0. So we can either use that feature, or we can also do it as an intersect. Okay, we're going to do it as a root first. So to solve an inequality on the graphing calculator using the root feature, first thing you have to do is get everything on one side of the inequality. Okay, so everything is going to be on one side, 0 is going to be on the other. Then we're going to calculate the root. Once we calculate the root, the answer is going to be one of 2 things. Because you're going to have something like this. Something in that box, and then maybe you'll have a symbol like that. Could be a less than, could be a greater than, could be an equal to. Could be any one of the 4 symbols. Once we type this in on the calculator, and we figure out where it crosses the x-axis, in this problem, the answer would be everything less than that number. If you had a greater than, then it would be everything that's positive, everything that's above that number. So that's your x-axis, and there's your line that you drew for an inequality. Your answer is either going to end up being everything down here or everything up there. It's always going to be one of those 2 pieces. Whether or not it includes exactly right there, well, that depends if you put the equal to in or not. Right? So you're going to look for where your answer is either in the negative section or the positive section. Okay. So let's try it. So let's graph the inequality 4x minus 1 is less than 2. Now, graphing is going to take longer than doing it algebraically in this problem. Because if you wanted to solve this algebraically, it's just 4x is less than 3. Done. X is less than 3/4. Okay, so we already know the answer algebraically. But you might come across inequalities that are not so easy to do algebraically, and then graphing might help. So let's try graphing on an easy one and see how it works. Okay, so for method 1, which is calculating a root, what do I need to make sure I have on one side? Yeah,
A 0.
a 0. What would be the easiest way to get 0 on one side of that inequality?
Subtract by 2 on both sides.
Yep, let's subtract 2 on both sides. And now let's put this in y1. 4x minus 3. And when I graph it, am I looking for where 4x minus 3 is below the x-axis or above the x-axis? Which one am I looking for in this case? Marcel?
Below.
Below. I'm looking for where it is under 0. So let's do zoom 6. And it does have to be under. It cannot be equal. It has to be under. So the answer to my problem, where is that graph less than 0? That's going to be everywhere in this section. So we need to find where it crosses the x-axis and then say it's every number less than that. So we'll do second calc 0. Find our 0. And it says that there is a 0 at 0.75. And we want everything that's down here. That means you want all your x's that are less than 0.75. Because as you head to the left, the graph is below 0. You can put 0.75 or you could put 3/4. You could do it either way. But it's exactly the same answer I got as when I did it algebraically. Is there any question how I calculated the 0 and then interpreted that I wanted everything less than that number? Yeah?
How do I do it on my calculator?
So you do second calc 0, and then you have to pick a point to the left, to the right, and then you have to do the guess. So you end up hitting enter 3 times.
My graph doesn't look like that.
It doesn't look like that, and you typed in 4x minus 3,
Yeah.
and you did zoom 6.
Yeah. It's like not even.
Oh, you put in some extra stuff there. You have this less than 0 thing. You don't want to put that.
Oh.
Yeah. You want to type it in exactly like what's right there, 4x minus 3. You can't actually type in an inequality symbol right here. If you could, then the calculator could interpret what you want. But on this calculator, you can't change that equal sign to a less than sign. It's always going to graph the line, and then you have to reason it through from there. Now, calculating a 0 is one way to do it. Or we can also calculate an intercept. With the intersect method, you don't have to get 0 on one side. You leave the problem the way they give it to you. You take the left side of the problem, you put it in y1. Take the right side of the problem and put it in y2. So it's the same problem we already did. This time I'm going to do it as an intercept. So take the problem that they gave me, put the left side in y1, put the right side in y2, do your zoom 6. Okay, so this is the blue line I drew. That's going to come up as the red one. That's the coloring that I used. I'm looking for where the blue line is less than the red line. That means where it's underneath. So to figure out where it's underneath, first thing I have to do is figure out where they cross. And then I can either say it's everything less than that or more than that. In this case, I want less than, because that's where it's underneath. So my answer is going to be everything in this section. I want to know what x values will land me in that section. And that's x values from here and down. Okay. The further to the left I go, the further underneath the red line I end up. Okay. All right, so let's do our intersect. So intersect. So it tells us those two lines intersect at 0.75. And because I want to know where the blue one is under the red, that means I want x values that are below 0.75. If I pick x values above 0.75, like pick an x value of 3, you're way up there when x is 3 on the blue line. That's not what you want. That's above it. Okay, you want under. So in our case, we wanted the x's that were below the intersect value. So 0.75 or 3/4 is the same thing. And I already did that. So example 4 and 5 were the same problem. I'm just showing you how to do it as an intersect versus a 0. Any questions on the two different ways you can do it? It doesn't matter which way you do it. You can do it any way you want. Okay, so we talked about solving a single inequality. Now we're going to look at solving a double inequality. There's a couple ways you can solve double inequalities. If double or compound. Right? If this compound inequality only has a variable in the middle, then the easiest thing to do is almost treat it like an equation. But when you do something to the middle, do it to the left, do it to the right. So if I was going to solve this one, I would say divide everything by 2. And I would get -4 is less than x, which is less than 6. So it's not bad when there's only a letter in the middle. You can do this approach. Just remember, whatever you do to the middle, do to the left, do to the right. So it's like an equation, but you have to do it in 3 spots. The problem comes in when you have variables in multiple spots. So like if you had something like -7 is less than or equal to 3x plus 5, which is less than 2x. Well, in that case, it might be easier to split that into 2 problems, right? And then just solve each one separate. So you might want to take this and write that as one problem. Solve that, and then take this and write it as a second problem. And solve that. So now what I've done is I've made it so I have 2 separate inequalities, and I don't have to deal with all 3 parts at the same time. It just depends. It depends on the problem. Okay. But I would definitely not take the approach of splitting it in this one, because there's only an x in the middle, and that's easy enough to use this method. Okay. So any questions on this idea? A lot of times when I have to graph something and I need to put it on y1 and y2, I will take the original problem and split it up. Then I have something I could graph. So it really just depends on the problem. All right, let's try this one. Is this a problem where you think you would want to split it into 2, or could we solve it without splitting it into 2? Yeah?
You could probably solve it without.
Yeah, we can do it without, right? There's only an x in the middle. It's not going to be too complicated. So there's 3 steps to isolate x here. What would be your first step? Yep.
Multiply by 3.
Yep, multiply everything by 3. Okay, If you multiply by a negative, same rule, you got to flip the sign, but we're not multiplying by a negative. So now you've got negative 9 is less than 2x plus 5, and you've eliminated the 3, which is less than or equal to 15. Okay. What would be our second step? Yep.
Subtracting this back.
Yep. And remember, you do it on the left, middle, right. That's gone. Negative 9 minus 5 gives me negative 14. And 15 minus 5 gives me 10. And my last step to get x alone, yep, divide by 2. Here, here, and there. Okay, so final answer is negative 7 is less than x, which is less than or equal to 5. If you had split this into 2 problems and solved it, you would have gotten x is greater than negative 7 for the left problem, and you would have gotten x is less than or equal to 5 for the right problem. So you could split it into 2. The key when you split it into 2 is, remember, you use the middle in both parts. So this is one part, and that is the other part. Okay, so again, I would use that approach when you have variables in multiple spots. All right? It's going to make things, I think, a little easier. Okay, any question on that? All right, so let's take a look. Let me see what we have. Let's look at this problem. So consider the set of rectangles where the length is 1 unit more than twice the width. Well, before I even read anything else, let's write that as an equation, because chances are we're going to have to take that information and change it into an equation at some point. How would you write that the length is 1 more than twice the width as an equation? Yeah.
So, no, assuming that we're using L for length, L equals 2W plus 1.
Perfect. Don't know how we're going to need that, but I bet we do somewhere. Length is 1 unit more than double the width. Okay, good. So we'll come back and see how we need to use that. It says find an algebraic representation of the rectangles that have a perimeter of less than 100. Okay. So let's make our sketch. We know that the length is 1 unit more than twice the width. So when we wrote it that way, which variable is our independent variable? If we try to put that in terms of like a function notation. Yeah?
Would it be our width?
The width, yeah. You're basically saying that the length is a function of the width. What function is it? It's double it plus 1. Okay. So the width is your independent variable. And that's your width. Now your length is double the width plus 1. So double the width plus 1. So just like when we've done perimeter problems in previous lessons, this one's a little different because they're giving you this information to create the labels for your sides. Now, once we have our labels, we can write a formula for, let's see, do they want to know area? What do they want to know? Find an algebraic perimeter less than 100. Okay, so this is just about perimeter. This one has nothing to do with area. How would you find the perimeter of that rectangle now? Yep.
You add up inside.
Yeah, and we know that the perimeter is less than 100, because that's what it says, perimeter less than 100. What's the perimeter of that rectangle? As simplified as you can do it. 6W plus 2. There you go. So that's an algebraic representation of the rectangles that have a perimeter of less than 100. 6W plus 2 is less than 100. They didn't actually ask me to solve anything in part A, but in part B, now they say, find the possible widths of these rectangles. So in other words, solve part A. Okay. So when we solve part A, you're going to minus 2, and you're going to have 98, and then 98 divided by 6. So 98 divided by 6, oops, type it in on the screen where you actually can do math, and type in the right problem. All right, so it's 16 1/3. Let's see, 98 divided by 6, that reduces though to 49/3. So the width has to be less than 49/3, but that's not all of it. What else do we know about the width? Yeah?
It has to be greater than 0.
It has to be greater than 0, yes. If you don't put greater than 0, you're technically telling me the width could be -10. -10 is less than 49/3. So in the context of the word problem, make sure we put that in. Might not even be a bad idea to put that in right there, to say that the perimeter is less than 100, but it's also greater than 0. In fact, we should probably put that in right up where we did. Yeah. Okay. Any question on that? Yes?
How'd you get 49/3?
Solve minus the 2 and then divide by 6. Solving that equation right up above. It's solving the inequality, not the equation. All right, so if we can solve equations with absolute value, we can do inequalities. A lot of the same kinds of rules. You have to make sure that when you are solving it, the absolute value is isolated. That's the first step. And then once it's isolated, you're going to split it into 2 problems. Now yesterday, we split it into, if we had this box here, equals, and another box, we said what was in this box could equal that number, or what was in this box could equal the opposite of that number. Okay? Either one worked. And today, it's pretty similar. So the first inequality is basically the exact inequality I give you, but without the absolute value bars. Now, the second inequality that I give you, we take away the bars. We always take away the bars because that's what we're trying to do. We're going to make it the opposite on the other side. That's the same thing. But there's one other thing that's going to happen. So you're going to have a symbol maybe like that. So you're going to take what's in that box and just say less than that number. You're going to take what's in that box and then make this side the opposite. We have to do one other thing when we make this side the opposite. Anybody know what else we have to do? Yeah?
Do you have to flip the sign?
Yes, we have to flip the inequality sign. So this is the extra part in step 2. So you take away the bars on the left side, make the number on the other side opposite, and flip the sign. So that's how you set up your 2 inequalities. Now, one other thing when we write our final answer. When we do an equation, we just say that x could equal 1 or x could equal 2. When you do an inequality, you're going to end up with 2 of them. You'll end up with an inequality here. You'll end up with another one here because you're going to solve two problems. There's a word that has to go between the two. And there's two choices for what word you put. Does anybody know what the two choices are? Yeah?
Would it be like
Or you could put or. And we have to put the right word because there's a big difference in math between or and. So if the original problem has less than or equal to, we use an and. Mathematically, that's called an intersect. Right? Think of a Venn diagram. If I said to you, tell me all the data points that are in A and B, it's where A and B intersect each other. It's the overlap. Okay, so that symbol, that's called an intersect. If you have a greater than or equal to, that is called an or. Okay, and that's a union. Union, that U symbol, it's called a union, and it basically means or. So if I had a Venn diagram, and I said, tell me all the data points that are in A or B, that technically means this is everything that's in A, this is everything that's in B, and the answer is everywhere that I shaded, including the overlap. So A or B for us basically means the whole thing. It's either this or this. It's all of it, not just the overlap. Okay, so the original problem is what tells you what symbol to use. Okay, so let's try an example. So first question, is that absolute value isolated? Where do we get Jackson?
It is isolated?
Yeah, it is isolated. It's by itself. We don't have like a 2 plus or anything like that on the outside. So we're good to split it. Can anybody tell me the first inequality that I'm going to split that into that does not have an absolute value bar in it? Vince?
Would it be like remove your bars and it would just be like x minus 3 is less than 3?
Yep, so the first one would just be x minus 3 is less than 3. How about the second one? Anybody tell me that one? What's the second one? Yeah.
Is it x minus 3 is greater than negative 3?
X minus 3 is greater than negative 3. So yeah, we did a couple things there. We took away the bars, we flipped the sign, and we made the number on the other side opposite. What word is going to go between those two? And? Or is it or? Which word? Yeah.
Would it be and or?
Which one?
And or both? Because they're.
You have to pick one. Yeah. You either can be this one or this one, but not both. Remember, we have to look at this original symbol. It's an and. So when you look back at the original problem, that had a less than in it. And by the way, I should clarify that. It's the original problem after the absolute value is isolated. Okay. So in this case, it is already isolated. So that's an and. Mr. Hager? Okay, so that's what we have to solve. And now let's solve each one. So x is less than 6. And x is greater than 0. And there's always kinds of ways we could put that together. We could write it as set notation. We could graph it. But that's how you solve an absolute value inequality. Okay. All right, let's take a look at, actually I'm not worried about that right now. Let's look at this one, some solving graph. What, anybody tell me, is the absolute value isolated in this case? Yep, it's already isolated. So what would be one problem I could split it into? Yeah?
3x minus 2 is greater than 1.
Greater than 1. The second problem I would split it into? Yep.
3x minus 2 is less than -1.
Perfect. And the word that would connect the two? Yeah? Or, because this is a greater symbol. Greater. That's how if you say it that way, it might help you remember it. It's a greater symbol. Greater is an or. Okay, and I'm not going to finish it from there, but you could finish that up, and that's how you solve that one. And that's another one. That one would be an and. Now, let's say you had times -1 in front of that. That's not isolated now. So the first thing you would have to do to get rid of this times -1 is divide both things by -1, both sides. When you divide both sides by -1, the -1 is gone from the left. It becomes -4 on the right, and that flips. Right? That would be important to remember. So now, if you were solving this one, once you've isolated the absolute value, look at the sign. It would be a greater than or equal to. Right? So this would become an or problem when you solve it, because that negative is going to flip the direction of that. If the negative wasn't there, then this is an and problem. All right, let's look at this one. I want to solve for when this is greater than 0. So think about what it means to divide two things and get an answer greater than 0. What has to happen if mathematically you divide two numbers and you get an answer bigger than 0? How can that happen in math? Yeah?
You just can't have zeros even when numbers.
What can you have that would give you a positive result when you do division? Yeah?
2 positive numbers.
You could have a positive divided by a positive. Yeah? Positive divided by a positive will always give you a result bigger than 0. What else could you have? Yeah?
Negative divided by negative.
You could have a negative divided by a negative, and that will also give you a result that is always bigger than 0. Out of these two cases, only one of them is possible in this problem. Is case 1 the one that could happen here, or is it case 2? Yeah?
Case 1.
It has to be case 1. Case 2 could never happen in this problem. Why can't case 2 happen?
Because it's absolute value.
Right, because you have absolute value in the bottom. So I guarantee you the bottom is never a negative number. If the bottom is never negative, then case 2 is not going to work in this problem. It has to be a positive over a positive. Since I already know the bottom is always positive, all I really have to do is figure out when is the top positive. If I can figure out when the top is positive, that will tell me the answer to this inequality. And the top is positive as long as x is greater than -3, but that's not quite my entire answer. X has to be bigger than -3, but there's something else. What else do I have to say about x? Yeah?
It cannot be 2.
It cannot be 2. So x can be any number bigger than -3, and that'll guarantee the top is positive, and the bottom is always positive, so I don't have to worry about that. But I can't divide by 0. That's why x can't be 2. So if you just said x has to be greater than -3, you're not quite right. You forgot about x not being 2. Okay. Any questions on that? Okay. So let me put up the homework. I'm not going to have time to put the list of topics on the board right now because we only have about 3 minutes. But I will put the list of topics in the video.